Does anyone know? Am I audible? People?
Yes.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay.
ma'am.
My question is, does any laser is? No? How many of you have played PUBG or Mortal Kombat or any of these sniper games? Not Mortal Kombat. Mortal Kombat does not have lasers. How many of you have played all these sniper games and commando games and all these things? Yes, no?
Yes,
Yes,
ma'am.
ma'am.
You have played. You've seen all these movies, right? Where there's this group of army people coming in and they have trained their rifles on some, not really unsuspecting, but some dastardly guy, and they're trying to tell that person, okay, boss, we have you in our sights. You've seen that, right? So you see those
Yes,
green
ma'am.
dots or those red dots on that person?
Yes.
Yes, no?
Yes, ma'am.
Yes, ma'am.
Right, so that is a laser. Okay, now, thankfully, in electrotherapy, we don't use that kind of a laser. We use something known as a therapeutic laser, which has got a much lesser uh, wavelength as compared to those other lasers, but the essential principle is the same. You are going to see a red focused uh, laser beam or a beam of radiation in the tissues where you want to apply this. Okay, so when we look at the acronym, this is light amplification by the stimulated emission of radiation. And the acronym itself tells you everything about how laser is being produced. Okay, so we have got light, so we have got a radiation which is amplified, which has been amplified. And how has it been amplified? By a stimulated emission of that radiation. Okay, are you understanding this?
Yes, ma'am. No, ma'am, please repeat it.
Yes, exactly. You have got a beam of light which is coming out from whatever applicator we are going to use. And how has that beam of light been produced? So it has been produced by amplifying a certain amount of radiation. How has that amplification occurred? That amplification has occurred when a beam or a photon of light has stimulated surrounding atoms, and it has caused those surrounding atoms to also emit photons of light. Okay, so that is light amplification by the stimulated emission of radiation. So we are going to need to stimulate the radiation and therefore amplify it. Okay, so we're going to look at all these things in detail as we go ahead further. Okay, before we go on to the actual production, we will need to identify exactly how laser is. Okay, so we are going to look at the principal characteristics of laser. Okay, what defines laser as laser? Okay, otherwise it is any odd radiation that we find out. You've learned about IRR. When we saw the electromagnetic spectrum, we saw that there were so many different kinds of radiation. Okay, so what separates laser from all these other radiations is what we look at first, and then we'll go back to how it is being produced and how each of these words, whatever you are seeing over here, how each of these words is actually being put into play. Okay, so the first thing that we are going to look at is the monochromaticity principle, characteristic. Okay, what does this state? Break the word up. Monochrome. You have heard of monochrome?
Yes.
Yes, ma'am.
Okay, most of these designers are going to, interior designers use, just spew this word out, monochrome design, etc., etc. What does that mean? It just means a single color. Okay, fine. So you might have come across descriptions like a monochrome design with a single spot of color, etc., etc. Okay, but monochrome essentially means single color. Mono is single or one, and chrome is color. Okay, so this is a single specific color because of the wavelength, that specific wavelength of the radiation. Understood this concept?
Yes, ma'am.
Okay, those who have understood this concept, they are going to raise their hands. Let me see. How many of you have understood? Okay. Good job. Why can't I see the participants? Yes. Okay. Has everyone understood? Bingo. You can lower your hands now. Thank you so much. So you have got a single color. This single color is because of a very specific wavelength. Okay. Fine. And this specific wavelength is going to give rise to that single color. You know the colors of the rainbow, right? Why do you get those colors? Because each photon is being emitted at a particular wavelength. Therefore, it is giving rise to that color. Okay. So each laser radiation is going to have a single color because of that particular specific wavelength. Okay. The second characteristic is something known as coherence. You have done coherence when you did sound waves in your 12th standard? Yes?
Yes, ma'am.
Right? So coherence, okay, coherence is where your radiation beams are going to be in phase with each other. Okay, so all the peaks are going to be together, all the troughs are going to be together. Okay, so that is spatial coherence. So at one point of time, they are going to be in that same specific phase. They're not going to be out of phase. They're going to be in that same specific phase. And the second thing is a temporal coherence, which means they're all going to travel in the same direction. You have seen the radiations that were emitted with IR. You needed a parabolic reflector to collect all radiations and pass them out in a single direction. Remember that?
Yes.
Yes? No?
Yes, ma'am. Yes.
Yes, ma'am.
Yes. So essentially what was happening, that one emitter of IR was giving out radiation in multiple directions. Laser does not do that. Laser gives out radiation only in one direction. Okay. So whatever process of the radiation is, it is going to end up with giving out radiation beams only in one direction. That is known as temporal coherence. Okay, so they are all going to be traveling in the same direction, in the same phase at the same time. Okay, so that is coherence. The third one is a new word. This is known as collimation. It is not collimation, it is collimation. Okay, so please look at the word properly. This is a new word, so I'd like all of you to write it down specifically. Okay, and you should have a flashcard for this one characteristic, because this is the only characteristic which you spell wrong. Okay, so collimation means that all these radiations remain in that parallel beam. They don't deviate from their beam. Okay, therefore, since they are traveling in the same direction and since they are not deviating, they are remaining parallel to each other, laser has the property of being able to traverse long distances. It is able to cover long distances. Okay, therefore, that example that I gave you, all these snipers and they're training their rifles on one poor person. not exactly poor person, one bad guy. And where are these snipers? They're almost 200 feet away, etc., etc. But the laser pointer has traversed those 200 feet and it is now being seen on that person. Okay, why is it so? Because it is following temporal coherence and collimation. Okay, I want you to pay special attention to the word collimation, COLLIMATION. Okay, please spell the word properly. It is not collimination. I will cut marks if I see the word collimination in your answers. Okay, you will automatically lose half a mark over there. Fine. Understood the three characteristics?
Yes, ma'am.
Yes, ma'am.
Yes. Fine. Now, yes, this is very important. They are going to have the same effects as light when they interact with matter. So when they hit something, okay, when they are directed upon something, they will scatter and they will deviate and they will show attenuation and they will show all the laws of radiation. Okay, but till they hit something, they are going to follow the first three characteristics. Okay, once they come in contact with another matter or another medium, only then will they start showing the sign, or only then will they start following all the laws of radiation. Okay, why is this important? Because right now we are looking at the production part, but in the second year, when we are looking at the use of laser in multiple injuries, you will need to understand how laser attenuates or how the energy dissipates when it goes into the body. Okay, so therefore we need to keep this in mind. Okay, so the moment the laser beam hits another matter or another medium, it is going to get reflected, refracted, absorbed. Okay, everything is going to happen to it, provided it hits another medium. Okay, look at the diagrammatic representation of all the characteristics. So this is the first one. This may seem that they are out of phase, okay, but this is the coherence that we are talking of. Okay, the first one actually, rather, this was the amplitude. Okay, so the amplitude of the wave is the same, which means that the wavelength of the wave is the same. Okay, the peaks and the troughs, they are spaced equally apart. Can you see that? Right, so you have one wave which is where the phase is equal to the subsequent phases and multiple waves have the same wavelength. Okay, so this is your monochromaticity or the single specific wavelength that is being shown over here. Then you are seeing that all the peaks are in the same phase. Okay, which means that all the troughs are also in the same phase. Okay, because they have the same wavelength. Fine. So all peaks and all troughs, basically all phases of these waves are going to be in the same phase. Okay, all points of these waves are going to be in the same phase. Okay, this is which coherence? At one point of time. Okay, then they are in the same direction. Okay, fine. So these two, the dotted red lines and the orangish arrows, they show the spatial and the temporal coherence. Okay, which means that the rays are in the same phase, excuse me, and the rays are traveling in the same direction. Okay, fine. And they are parallel to each other and they will remain parallel to each other, which brings out the third characteristic, collimation. Everyone understood this? Yes, no,
Yes, ma'am.
Yes,
right?
ma'am.
Yes, ma'am.
Clear with this? Do you
Yes,
want me
ma'am.
to explain any concept again? Would you like an explanation of any concept? No? So we'll go ahead. After this, we're going to start with production. Okay? So the production of laser. Do you know how the atom is structured? You've got the nucleus in the center with protons and neutrons. So the positive and the neutral charges are collected at the center. Yes, you've done this. Yes, no?
Yes, ma'am.
Yes, ma'am.
Yes. And then you have energy shells. Correct? You have got energy cells around the nucleus where you are going to accommodate all the electrons. Right?
Yes, ma'am.
Right? So you have got lower energy shells and higher energy shells. Correct? So when you are looking at the structure of the atom, which is very important over here, you will understand that you have got a nucleus which contains the positive and the neutral charges, and you have got the energy shells, okay, which contain the negative charges. Okay, and the positive and the negative charges are going to attract each other, therefore maintaining the integrity of the atom. Okay, now what happens is you have got an electron over here. Can you see this orange dot? So this is an electron. This electron is going to remain in its energy shell until and unless it is acted upon by an external force. Which external force can act upon an electron? There are multiple forces that can push an electron from a lower energy shell to a higher energy shell. Okay, one of that is temperature change, pressure change, but the most important one is photons or radiations, which can have an impact on the atom. Okay, so what happens is the photon is going to stimulate the electron, which goes to a higher energy shell. Okay, and when it goes to a higher energy shell, it is there for a specific amount of time. Okay, I'm going to go back. You've got a photon of light, this yellow star, which stimulates the electron. It goes to a higher energy shell. Okay, what happens when it is at the higher energy shell is it has gained energy. Because of that gain in energy, it has gone to a higher energy shell. Okay, but that is an unstable state. It does not remain in that state because it is not its original state. Okay, therefore what happens is the electron is going to jump back to its original shell. Okay, so from a higher energy shell, which is this outer line, it is going to jump back to its original shell. Okay, when it jumps back to the original shell, it has given out that excess energy. Okay, and that excess energy is these two red dots, which indicate an amplification of the radiation which was originally given. Okay, so you have an electron which is acted upon by a photon of light which jumps to a higher energy shell, and when it comes back to its original shell, it gives out more photons of light. Okay, now this is happening with one atom. Okay, if multiple atoms act in a similar manner, you are going to get laser. Okay, understood this concept? Would you like me to explain it again? Have you understood this concept?
Yes, ma'am.
Everyone? Those who have not
Yes, ma'am.
understood, please raise your hands. Those who have not understood, please raise your hands.
मॅम
Yes?
मॅम जे फोटॉन ऍक्ट होतात ते सब थ्रेशोल्ड असतात ना?
No, they are not sub-threshold. What do you mean by sub-threshold?
म्हणजे फोटॉन ऍक्ट केल्यावरती इलेक्ट्रॉन सेलच्या बाहेर गेला पाहिजे, आय मीन ॲटमच्या.
नाही. शेल ॲटमच्या बाहेर नाही जात तो. It goes to a higher energy shell.